Okay, so after we had our conference, I realized that we did not finish talking about limiting reactant and that we probably need to come on here and explain the idea behind limiting reactant and excess reactant. Okay, so limiting reactant problems, you're always given at least 2 reactants and you have a product. Sometimes you have multiple products. A lot of times you have multiple products. But in each one of these, you're given a certain amount of A and a certain amount of B. Sometimes this is in mole, a lot of time it's going to be in gram, okay? So I think the problem with limiting reactant for most people is that it's not necessarily as cut and dry as everything else because the problems can look quite different. But the consistency with limiting reactant is you're always given a certain amount of A and a certain amount of B. And normally you are just asked, which one of these is limiting? Okay? When you're asked that question, you have to solve for either C or D. Okay? Just pick one. Oftentimes I pick the first one I see or I pick the easier one. It doesn't matter. And you get to pick right here. So you can solve for C and you can pick, do I want to do a mass to mass? Will that make it more consistent in my head to solve for grams of C? But if it doesn't specifically ask you for grams of C, then you don't have to solve for grams. You can stop at moles if you want. But again, this is also kind of your choice. When the question is which one of these reactants is limiting. Sometimes the question will not be which one is limiting. Sometimes the question will be specifically how many grams of D do you get? Okay, so you just have to read your question. You have to start with your givens. And in every limiting reactant problem, you are going to have 2 givens. You're going to have one for A and one for B. And your goal is usually going to be which one is the limiting reactant. But sometimes you are asked for a different goal, a very specific goal. How many grams of D do you form? Okay, so again, just to kind of restate, if you are asked for which one is limiting, okay, it doesn't matter. Solve for either, okay? But you have to solve using A and B for the same compound. Okay, so you can pick which one you want to choose when this is your question, but you can't pick one and solve A for one. Say you want to solve A for C and you want to solve B for D. That does not work, okay? You cannot do it that way because you have to have something in the product. You have to have some type of product that you can compare. So not only should it be the same compound, it should also be the same unit, okay? So if you are asked which one is the limiting reactant, you have to solve A and B for the same compound and the same unit. It doesn't matter which one you choose. It doesn't matter if you want to solve for C or D or moles or grams. You just have to be consistent. Now, other times it will specifically ask you for grams of D or moles of D or grams of C or whatever. It just gets more specific, and when it gets more specific, it actually is a lot easier. So the idea of this is that you have 2 givens, and you want to know which one of these runs out first. So in a lab setting, we put a certain amount of A in, and we put a certain amount of B in. We put these together, we combine them by basically putting them in the same beaker or the same glassware, and then we get some type of product out. Okay, let me rewrite that. Let's say we get C plus D out. Why can't I draw a D? Okay, and basically our question is which one, A or B, ran out first. Okay, so that's which one is limiting the amount of product that can be made. So let's work an actual problem. So this one, let me kind of make some separation here. Okay, so it says determine the limiting reactant. So notice this one is a wide open question. It is asking us, oops, let me pick a color. Determine the limiting reactant. It is asking us which one is limiting between these two. Okay, So it wants to know which one is limiting, 2.0 moles of hydrochloric or 2.5 moles of sodium hydroxide. So when it is asking us this question, it is leaving it wide open, okay? We just want to know which one of these two runs out first. So because it is wide open, I'm going to pick a product, sodium chloride or water. I'm going to pick sodium chloride because why not? So I'm going to solve for moles only because that is easier than solving for grams. So that means that my first step is to take 2.0 moles of hydrochloric. Okay, that's my given. And I want to know how many moles of NaCl I have. I have to do the same thing, but my given is now 2.5 moles of sodium hydroxide. And I want to know how many moles of sodium chloride I have. And once I have these two, I can take, I can take the answer I get there and the answer I get here and compare them. And I can determine which one of these reactants ran out first. So let's do the first step. Number 1, 2.0 moles of HCl. We're in a good spot because this reaction is balanced with just coefficients of 1. So this is a super easy problem. So since I have moles of HCl down here and I'm looking for moles of NaCl, I want to use my actual reaction to my equation to go from HCl to NaCl. So to do that, this is just a mole to mole conversion. So I use the coefficients and I get 2.0 moles of NaCl out. Okay, so this gives me 2.0 moles of NaCl. Let's do the same thing, but for number 2. So for number 2, my given is 2.5 moles of NaOH. Again, this is a mole to mole conversion. So mole to mole conversions, I use the balanced equation and I go from NaOH to NaCl. And the coefficients 1 and 1, this gives me 2.5 moles of NaCl. So you notice I solved for the same compound, NaCl, NaCl. I solved for the same unit, mole, mole. So this number 2 gives me 2.5 moles of NaCl. So basically, I can compare 2 moles, let me use a different color. I can compare 2 moles of NaCl with 2.5 moles of NaCl. And I can say, well, 2 moles of HCl gave me 2 moles of NaCl. 2.5 moles of NaOH gave me 2.5 moles of NaCl. So the lower number is 2.0 moles of product. So that means your limiting reactant is the 2.5 moles of HCl. I mean 2.0, my goodness, 2.0 moles of HCl. Why can't I talk? So this is your limiting. Okay, if that is your limiting, that means that this has to be your excess. All right, so let's talk about excess. Oftentimes we are asked how much is left over. So this one is pretty much the same steps every single time. So how much is left over? You are going to take the limited product. Okay, so what was the limited product? That was the smaller one, 2.0 moles. So this is your new given. And you are going to solve for how many moles of the excess reactant. Okay, hold on, let me rewrite this. So what I'm saying is, say I put 2.0 moles of HCl in, and I put 2.5 moles of NaOH in. I will only get 2.0 moles of NaCl out. So how much of this 2.5 moles of NaOH did I use? So I'm doing the same idea, but I'm going to flip it. So now my given is actually my product, and I'm just solving for how many moles of NaOH that I used. Okay, so I'm going to start with my given, 2.0 moles NaCl. I want to know how many moles of NaOH. So when I'm doing a mole-to-mole conversion, I just use the chemical equation. So now I'm just going backwards from NaCl to NaOH. And the coefficients for both are 1. So this means that I used 2.0 moles of of NaOH. That's how much I used. So to know how much is left over, I was given initially, okay? So I initially put into my little pot right here. You remember when I put in a certain amount of B? Well, my certain amount of B was 2.5 moles. I put in 2.5 moles into this solution, okay? Well, I only used 2 moles, okay? So how much is left over? You're just going to subtract the 2, and you have 0.5 mole of NaOH just sitting there, not used, okay? So this is our answer to this question, okay?